All right. Okay. So the title of this talk is Early Human Migrations, discrediting the myth of purity from a both historical and scientific perspective. Now, I gotta tell you, so often we focus upon what divides us as humans rather than what unites us, buying into the illusion that we are to be categorized into this or that group, when in reality, we are very much the same in the grand scheme of things. We are all humans, all of us arriving out of Africa and then gradually spreading across the globe. About 2 million years ago, humans in the form of Homo erectus migrated out of Africa. Next, Homo heidelbergensis emerged out of Africa, reaching Europe in about 600,000 BCE, roughly. The likely origins, of course, of Neanderthals and Homo sapiens, the latter, us, right, humans. Rather than staying in isolation, the Homo sapiens migrated to wherever they deemed best for survival, inclusive of climate and food sources. And while doing so, met other humans and they encountered along the way. Oh, and of course, with whom they readily mixed, including Neanderthals and Denisovans, which we'll talk about. When it comes to our actual DNA, there is no such thing as, purity. In regards, it's not true. Homo sapiens then continued to spread over the entire globe with isolation virtually impossible as one group migrated and mixed with the other. This includes Europe, one of the most mixed areas of all, with the idea of purity of race in this region, as advanced by some even recently, being a complete fabrication based upon prejudice and ignorance. You know, we are a bunch of mutts. We really are, from the grand scheme of things. You see, about 4.6 billion years ago, the Earth was formed with this era known as the Hadean geological age. And I want to say, in the grand scheme of things, we as humans have not been here in this current form for very long. Let's take a look at the first chart. While the Earth has been around for 4.6 roughly billion years, we have only existed as Homo sapiens about 300,000 years ago. If we now place Earth's existence into a 24-hour day, we humans have been here for the last roughly 3 seconds. I'll say that again. If we place Earth's existence into a 24-hour day, we humans have been here for the last sort of 3 seconds. Hence, although life would appear around theoretically 4 a.m. and land animals around 10:24 p.m., with dinosaurs going extinct around 11:41 p.m., we humans would not come upon the world stage until around 11:58, 11:57, 11:58. Some will say 11:58 and 43 seconds p.m. So we humans often see ourselves as larger than life, but life and existence is vastly larger than us. Let's go back to me. So, of course, we get even smaller when you figure out our Milky Way galaxy, which has been around for, for a long period of time. By the way, it has about 100 billion stars, with our sun as only one of them. And we're not even at the center, right? We're on the outer Orion arm, a minor spiral towards the edge of the galaxy. This galaxy, of course, is 13.6 billion years old. And it's not even the only galaxy. It is estimated between hundreds of billions to, 2 trillion or more. That's a lot of galaxies floating out there. We are just the tiniest blip. Earth as a planet is no longer as unique either. It has been estimated to be around 2 billion in our galaxy alone, with, of course, Earth-like planets, right? Would be about, I'd say about 50 billion, right? So we are very small, right? And then, of course, if you consider the Drake equation, which estimates that there could be as many as 12,000 alien civilizations in our galaxy. They're just estimating. And then you figure in the 13.6 billion years, when could this life appear? All of this brings us about a sense of wonder. We are just a very small piece of the puzzle. But sometimes our hubris gets in the way of that factor, does it not? And so this talk is about the grand scheme of things. It's about the grand sweep, so to speak. When we take a look at this, of course, we got the Earth started. Let's keep going, because I want you to feel the grandeur of all these ages that have come before us, and then we will arrive at the stage here. So we know that directly after the Earth was formed, water, which is one of the basic components of life, appeared. Water, of course, is produced as a result of star formation, right? When the stars are created, there exists strong winds of gas and dust, and the dust and heat compressed together. And well, yeah, water, of course, is to be found. It's not unique to Earth. It's found everywhere in the universe. In fact, for example, on July 11th, 2011, they estimated that around one quasar located about 12 billion light years from Earth, scientists detected a giant water vapor cloud that has 140 trillion times more water than all of the Earth's oceans combined. Or what about the Orion Nebula, right? Is so large it produces enough water each day to fill the Earth's oceans 60 times. Water is also not that unique. Well, now, despite the unusually high temperatures, calculated to be around 230 Celsius, 446 Fahrenheit, the unusually forceful atmospheric pressures, which really is the equivalent of having 27 atmospheres, by the way, as caused by the heavy CO2 atmosphere. Because of this, water was still in a liquid state, and so the surface of the Earth was covered in a liquid ocean. So it is a unique situation, a very unique situation, but not so unique in the grand scheme of things, as I mentioned. And so it is estimated that single-celled life formed around 4.2 billion years ago, during a time when Earth was bombarded by many asteroids, known as the LHB, or the Late Heavy Bombardment Period. In fact, let's go to another image here. In fact, as of 2017, the earliest microorganisms were discovered in a hydrothermal vent in, of course, the Nouveau-Tique belt in Quebec, from fossils that date back to around 4.28 billion years ago. Because the Earth only formed 4.54 billion years ago, and the oceans only 4.41 billion years ago, this evidence, we can go to the next one too, this evidence suggests an almost instantaneous emergence of life upon the planet. Now, other remains of life were discovered in Western Australia and date to around 4.1 billion years ago. But that happened pretty quickly. It was indeed spontaneous. Let's go back. Thank you, Margie, for showing that. So all the building blocks for our form of life that would eventually emerge were already here. For example, the carbon compounds, right? These elements were present in our oceans, possibly getting there through falling comets and asteroids. We also had just the right environmental conditions. Still, all of this coming together in a way that it did so quickly can be understood as miraculous. But again, not entirely unique. I am still in awe of it all. I love the process. Now we move on. And what happens is that we enter the Archean period of time, eon of 4,000 to 2,500 billion years ago. That's a long time ago, right? A lot of volcanic activity, constant lava flow. You know, most people take this era for granted because granite was formed during this period of time. I'm sorry, I worked hard for that joke. Moving right along. so so around then about 3.7 billion years ago, we have discovered the earliest evidence of what is called the stromatoliths. So you have, of course, obviously the Greek stroma, layer, stratum, which are layered biochemical structures, and they formed in the shallow water. And so they basically trapping and binding various grains. And then, of course, you're going to have the earliest appearance of oxygen occurs around this period of time, possibly between 3,200 to 2,800 million years ago. And so this enabled the ability for photosynthesis as a means to thrive. And of course, we know this is a process whereby light energy synthesizes sugars from carbon dioxide, releasing oxygen as waste, occurring around the same time. And so we have blue-green algae that comes about, if we want to use that name, or eukaryotes, right, so forth. So then after that, we move on to the next period. It's the Extasian period, kind of skipping a few, 1,400, 1,200 million years ago. We're still here, but the reason why I'm bringing this one up is that this is the first evidence for sexual reproduction. So this is happening. And of course, this is now red algae coming about. And so we're at the grand stage of things, getting ready for multicellular life. So we're going to move eventually from simple life forms to more complex ones, right? And I know you're waiting for this moment. Eventually, let's go to the next image. It's time for the arrival of one of the earliest things that you see all the time that you use by your sink. It's time for the arrival of, ta-da, the sea sponge. The sea sponge. Sponges arrived around 760 million years ago. So this is a multicellular parazone organism, right? So water basically constantly flows through them in order to obtain food and oxygen and to remove the wastes. I mean, they're here for a long period of time. And then we go to the next picture. Another life form was known as the Cambrial, which appeared around 558 to 555 million years ago. This was a slug-like organism. It was fed by scratching the microbial surface on which it dwelt in a manner similar to gastropods. Some people say this is the first form of early mollusks. Thank you very much, snails. They lived in the shallow waters and ate bacteria and algae. And then I had to show this one. This is one of my favorites. Let's go to the next image. Then, of course, the Namocalthus. Doesn't this look like some kind of alien life form? The Namocalthus. It thrived 549 to 542 million years ago. Very unusual shape, as you can see. It has this cup connected to a stalk. You can see how narrow that is. And then the next image, and then sometime between 600 to 540 million years ago, we're going to get our jellyfish. The jellyfish have arrived, and they've been stinging us and stinging me apparently last week ever since. So nothing but loads of fun. But these have all been around for a very long time. And then, of course, we go into the Phanerozoic Aeon, right? We're going to get the multicellular organisms, simple and soft, lacking bone, shell, or other hard body parts. Then, of course, jumping past to the Cambrian explosion, boom, right? And then we go on to around 450 million years ago. Next image, we get the horseshoe crabs. They evolved, living. They're invertebrates, lacking a spine, right, and live about the shallow ocean waters. Going about there, and you can see they have compound lateral eyes. So pretty interesting. So they both detect visible light and ultraviolet light. In fact, this horseshoe crab had 5 additional eyes on top of its shell. Despite its poor eyesight, the animal has the largest rods and cones of any known animal. I mean, 100 times the size of humans. And their eyes are a million times more sensitive to light at night than during the day. So obviously, they're doing much of their work towards the evening, right? And then, of course, we're moving on to the next period of time. Next image, the Silurian geological period. And so we have the start, of course, fish becomes more diversified. That's one big thing that happens. We also have these vascular plants do appear. We also have terrestrial arthropods. They have external skeletons, segmented bodies, right? In fact, so that comes about. And then let's go. This image, I'm going to tell you, to me, this is interesting. But of course, life upon the land with all its oxygen was very challenging in this new land environment, which lacked the marine mineral antioxidants necessary for survival. So guess what happens? Who prepares the way? Thank you very much. Brown algae kind of started the way. They started to creep and crawl on the land, preparing it for what is to come about soon. So you basically have the formation of these microbial mats. And then from there, other living species stuff can go, like green algae and so forth. Lichens, right? The old ancient lichens appear, preparing the way for life. Let's go to the next one. So there it is. Hey, we're still not here yet, but what is this? The oldest known air-breathing animal. It's called a Pneuma modesmus. Pneuma, notice the word spirit. This is kind of like a millipede. It thrived around 428 million years ago. So there you have that. So, and then of course, eventually go to the next image. Yeah, we're going to get insects. Now, we're kind of jumping the gun here, but the Devonian period saw an increase of land introverts, excuse me. I'm drinking water right now. Sorry. About 450 million years ago. By the way, the arthropods were perfect for colonizing the terrain. And then our favorite insects arrived about 400 million years ago. They're small at first, but eventually, within a few million years, they're going to be pretty darn large, like this firefly that you see here. Next image. The other thing is that, did you know there's a time where trees ruled the world? That trees were in charge. That's right. So I know we always think of time of the dinosaurs. We always think of time for humans, but there was a time for the trees. And so, so what will happen here is about 383 million years ago, the trees start to grow and to dominate the earth. These, tree-like plants have fern-like leaves that spread across the globe. In some cases, they look like a top-heavy Christmas tree, do they not? Right. They reproduce by releasing spores rather than by producing seeds. The anthropologist Scheckler notes as follows. he said that they had a major role in transforming its environments. I will quote. He says, its litter, he says, fed the streams and was a major factor in the evolution of freshwater fishes, whose numbers and varieties exploded in that time, and influenced the evolution of other marine ecosystems. It was the first plant to produce an extensive root system, so had a profound impact on soil chemistry. And once these ecosystems changed, they were changed for all time. Look, the trees are the heroes. It was a one-time thing, unquote. Yet these trees became so abundant. I want you to get the idea of how abundant this is. They became so abundant that they actually changed river systems from mostly braided to mostly meandering because their roots bound the soil so firmly. These trees become so abundant, they change the trajectory of various rivers. I don't know. I think that's great. Next image. Eventually, we have these thick forests. Now they're more of a scientific looking, so you can see them better. These trees, these archaeopterysis, right? So carbon dioxide, of course, obviously is being released in the atmosphere in great measure, but it does produce a greenhouse effect, and that's causing an ice age later on. So maybe too many trees. But I just want you to think to yourself, 383 million years ago, and continuing for millions of years, the trees are in charge. They are large and in charge, and I just love that. So there we go. And then of course we move on to the next image. Of course, now we're going to move on, and you have the formation of tadpoles, tetrapods, right? The labyrinth dodontia, right, comes about. I love labyrinth dodontia. So, of course, obviously, labyrinth, maze-like. Odontia from dentist in Greek. Obviously, this is teeth. It has a strongly folded tooth surface and a massive skull roof. And so we do have these complex creatures coming about. This is still during the time when even in the during the time of 370 to 360 million years ago, but even all the way into the 2,998 million years ago, you still have, of course, the world is just absolutely covered with all of these trees. So it's still a very tree period of time. And then, of course, we move on, and we're going to get what resembles cockroaches, right? Let's go to the next image. And then, there we go. During the Carboniferous geological period, roughly 330 to 298 million years ago, it features the ammonites. They appear on the Earth, which are able to produce eggs that can survive in a dry environment. And there's two groups of them, known as cynipsids and sauropsids. The cynipsids for being beast-faced. This includes mammals, every animal more closely related to mammals. The sauropsids are lizard faces, and you can see what's going to happen as a result of this one, right? But then, next image. So we have a mass extinction. And you're wondering, well, why are you talking about mass extinction? Well, guess what? It can happen on Earth then. It can happen again. This is the famous Permian Triassic extinction. This event wiped out almost all land vertebrates, as well as the great majority of other life. In fact, the Permian Triassic extinction was the most severe in Earth's entire history. Get this. Even in the oceans, 96% of all marine species were destroyed. 70% of all terrestrial vertebrate species became extinct. This is the only known mass extinction of insects. They come back. So you're going to have this extinction last for a very long time, as you can see here, millions of years, right? But what caused it? There's many different theories. Some say that there was a catastrophe. Some others say that it's a gradual process. Those say it's catastrophe say that maybe it was an increased amount of volcanic eruptions and a sudden release of methane from the seafloor. Maybe, possibly. Those who say a gradual version of the story includes sea level changes, increased anoxia, increasing aridity, so forth. But there you have it. And then, of course, we go into the Triassic geological period of time. So there you have that. Okay, so moving right along, next image. We're still not around yet. We're still not here. And we have, of course, the previous obscure sauropsid group becomes the most abundant and diverse of the terrestrial vertebrates. And so, of course, these are the ruling lizard forms. The dinosaur forms, right? So here we go, and the beginning of the dinosaurs. The dinosaurs thrived between 243 to 66 million years ago. Why are you bringing this up, you may ask? Well, I'm bringing this up because we haven't survived. We haven't been here that long. Dinosaurs, we always think, oh, dinosaurs, long time ago, too bad they didn't last very long. Well, 243 to 66 million years ago, that's a long time. They were the dominant group, the dominant land vertebrates during the Jurassic and the Cretaceous periods. What I'm trying to say here is we had this long period of time, millions of years, where trees dominated. Now, then there's of course this horrendous catastrophe where the majority of life gets wiped off the earth. And then next, all of a sudden, we have the dinosaurs are in charge. And we are just the smallest group on that very long chronological scale, right? Think about that. Think about that. Of course, we will have eventually the first birds are going to appear. So, which I'm thankful about, right? Let's go to the next image. Of course, this is an image of a real dinosaur that was discovered. You can see there, these dinosaurs have horns or crests, bony armor and spines, right? These, of course, were the largest land animals of all time. Oftentimes, they reached 39.7 meters or 130 feet in length, and in height 18 meters or 59 feet. I mean, these are enormous creatures. By the way, I told you that they're related to birds. Actually, did you guys know, a little bit of fun trivia, dinosaurs slept with their heads tucked under their arms? Okay, I just thought that was cute. All right, moving right along. So we know now we move into the area that eventually, of course, we're going to get the snakes. Let's go to the next image. Around 150 million years ago, snakes appear in the fossil record. In fact, we find that snakes often ate dinosaur eggs, and this is an example of a snake about to have a dinosaur egg, but apparently the environment decided to freeze this moment in time, and nothing occurred. Again, the first birds evolved during the late Jurassic period of time from small predatory theropod dinosaurs. So your birdie friends, congratulations. You have dinosaur friends. You always want to have a dinosaur friend? You got one. Okay. Yeah, well, of course, I have lots of dinosaurs I like to talk about, but I'm not going to be talking about any of them. That's another talk altogether. But good things do come to an end eventually, and we get to the next image, and the dinosaurs do become extinct. There's various beliefs. The bulk of the evidence suggests that there's something that hit the Earth 5 to 15 kilometers or 3.1 to 9.3 miles wide and hit the vicinity of the Yucatan Peninsula in southwestern Mexico, creating the approximately 180 kilometer or 110 mile crater and triggered another mass extinction, which includes the dinosaurs. Now, again, you're thinking, Dr. Rietveld, why are you talking about this? Because I want you to understand you got periods of the dominance of certain creatures or living organisms, and then you have these periods of extinction, and their periods lasted forever. I mean, a long period of time, very long period of time, but all good things come to an end. Huh. I wonder about us, although we haven't been here for very long. Next image. Well, the dinosaurs disappeared. So who's going to take over? Of course, mammals. Mammals develop from four-limbed vertebrates known as tetrapods, and they become two different groups: amphibians, living in aquatic environments and lay their eggs in the water, and ammonites. We talked about them. They will include reptiles, birds, mammals, and so forth. Now, the ammonites will divide between the Sauropsids, or the lizard faces, which of course will involve the dinosaur, and the Synapsids, which of course are the beast face. We talked about that. But you can take here, you can see how, of course, that's before the Great Extinction. But you can see the mammals, were alongside the dinosaurs, but they were not dominant. They were just kind of off to the side, and they were basically food. But they were also warm-blooded, right? By the way, also towards about 5 million years ago, we do get the mammoth. I just want to throw them in for fun. But now we get to the primates. Next image. This is an early primate. And of course, this is a Plesiodoppus around 58 to 55 million years ago, originated from North America, crossing the land bridge, connecting with Greenland onto Europe. This is theoretically kind of where we're going here. Okay, I'm going to show you the next one, and I want to see my face a little bit. But I want to show you this one just to start off with. So now we're going to get into the formation of humanity. And of course, what we have to understand is humanity has various migrations in different forms. So here we go. So let's see me for a little bit, and I'll just kind of explain how this works. So basically, the primates split into two different groups. You have the Haplorhini and the Strepsirrhini. What will happen is the Haplorhini, or the simple nose, this includes the simians, and they will eventually, this group will lead to the evolution of humanity. Meanwhile, the other group, the Strepsirrhini, they become a suborder of primates, which will include many, for example, the bush babies and so forth. Moving right along, now we're focusing on us, right? So now remember, we are the Haplorhini. Now the Haplorhini, they in turn split into two groups. You have the Tarsiformes and the simians, also known as the Simianformes. They divide from one another about 6 million years ago. Now the Tarsiformes, they become a group of primates. These primates once ranged throughout Europe and North Africa and Asia, everywhere. North America. They're now extinct. But the simians, or the Simiphorus, they will emerge out of Africa. Wait, they will emerge out of Africa? This is a migration, right? And colonize South America, because everything's kind of closer together, around 40 million years ago, giving rise to the New World monkeys. Okay, the remaining simians, the ones who stay in Africa, They're known as the Carterines. Eventually, around 25 million years ago, the Carterines will then split into the Old World monkeys and those known as the apes. And of course, this is a superfamily known as the Hominodia. The Hominodia it will include us eventually. I mean, we're part of the all down the line. So we're kind of in the ape category at this point. Now, the Hominodia, yeah, this is crazy, isn't it, right? Will split into two groups. Now, the Hominodia will split into the Hominidae, connected with the great apes, and the Hylomithidae, connected to the gibbons. This is around 20 to 15 million years ago. Are we having fun yet? Well, our ancestors will eventually are connected to the Hominidae. So you know, we're kind of with those great apes. Now, within the subfamily of the Hominidae, we have the remains of what's called the Nacopithecus. And of course, they were eventually, they're very close to the last common ancestor of gorillas, of chimpanzees, and of humans. They thrived around 10 million years ago. Now, of course, there is an extinct subfamily of Hominidae known as the Oranopithecus, which thrived around 9 million years ago. This was actually a Eurasian great ape and so forth, right? Now, the Hominidae will split into two groups. Again, yeah, wow. The Hominidae and the orangutans. And next, the Hominidae will split into two groups, the Gorillinae, and it will become the gorillas, and the Hominidae, which is our line that follows a ladder. So we're happening, you know. So the earliest Hominidae tribe was known as the Sahelanthropus. Dates around 7 million years ago. It appeared very shortly before humans then separate, and from, of course, will become the chimpanzees. So we are related very close to our chimps. They are the champs, and you kind of see that, right? So kind of like this. So if you want to follow the line direct, I don't know, I'm having fun. Basically, humans, first you have the Halprophines, moving to the simians, moving to the Catarines, moving to the Hominodia, moving to the Hominidae, moving to the Humanae, moving to the Hyrinae, moving to Australopithecus, Aphronis, and of course, eventually Homo. So, okay, there we have it. So are we appearing yet? Well, yeah, we're appearing. We're getting there. And of course, that is let's go to this next image. The Australopithecus afarensis, which basically means southern ape from afar. It lived between 3.9 to 2.9 million years ago. That's a long time ago. The most famous, of course, fossil related was discovered in 1974 in Africa, near the village of Hadar in the Awash Valley. This is in Ethiopia. It was by Donald Jonasson. He was a paleontologist from the Cleveland Museum. Officially, it's called AL2881, but we know it as Lucy. You see, it was she was named after the Beatles song "Lucy in the Sky with Diamonds," which, by the way, happened to be constantly playing at the campsite the day of the discovery. So Lucy, it will stay. This creature had a small brain like a chimpanzee. However, you take a look at its pelvis and its leg bones, almost identical in function with those of modern day humans. It showed that this species were hominins, and it did stand upright and was able to sort of walk erect, right? Now, the Australopithecus afarensis This, of course, the hominid tribe here split into the Homo group and the Pan group. The Pan group, of course, will be the chimpanzees, with our line following the Homo group. And Australopithecus afarensis connects directly to us along this evolutionary line. So we are indeed, the chimpanzee is indeed the closest related to us. Again, they lived between 3.3 to 2.1 million years ago. Look at the eye orbits, teeth, right? There is a interesting, just fascinating. Okay, so next image. But Lucy and those that follow, and of course the Homo group, they start making stone tools. Yes. So the use of stone tools occurs around 26 million years ago, right? During the what's called the Paleolithic, beginning of the Paleolithic era. The Paleolithic era starts with the creation of stone tools. So 2.6 million BCE to 10,000 BC. That's basically the Paleolithic era. And they call this first phase from 2.6 to 1.6 million BC. They call this the mimetic modeling period of time. So basically, in short, the object is what it is. It is what it looks like. You know, not much variation. You just kind of chip a bit of it here and there, and you can use it for cutting. You can use it for digging, or you can use it for knocking your friend on the head. All different kinds of uses. Let's go to the next image. So we got tools starting, and of course these tools connected to the Homo, or also known the formation of what's called Homo habilis. This evolved from Homo. Homo habilis, like the Australopithecines, thrived in the early and middle Pleistocene, roughly 2.1 to 1.5 million years ago. Homo habilis gets the credit for mastering the use of stone tools. They even made their own tool kits, which is pretty sophisticated. So there you have that. And the Homo erectus, they will start to they will also start to spread. I also want to say the Homo erectus were the first to make fire. I should mention that, inclusive of the use of fire to cook their food. And they survived as hunters and gatherers. So we do have evidence of that. Let's go to the next image. You said you're here for the idea of the Great Migrations. Well, guess what? We're getting the Great Migrations, just not what you expected. Early on, Homo erectus begins to migrate from Africa due to climate changes that made certain areas turn to desert. And so they arrived in Eurasia soon after. And then, of course, we find evidence of them spreading all the way across in Africa, but also moving on to India. They moved to China, Vietnam, and Indonesia. So this is the beginning of the migrations. That means that the Homo erectus will survive for quite a while. So this is the first hominid migration. And as you can see, I think this is pretty exciting. They're everywhere, right? The next important species of humans. Let's go to the next image. Oh, actually, this is of course the hominid species. I like this image here. Okay, here it's known as a Homo heidelbergensis, thriving between 600,000 to 200,000 years ago. You can see on this map here, with its fossils discovered in Ethiopia, Namibia, and South Africa. This species had a very large cranial capacity. Its brain was nearly that as large as humans. In fact, Homo heidelbergensis were able to speak to one another in a manner close to humans today. So the morphology of the outer middle ear suggests that they had an auditory sensitivity similar to modern humans, which is very different, by the way, from chimpanzees. They're able to also differentiate between many different sounds. It looks like that their mouths were able to, in a sense, form language. They're able to speak and speak in a more complex way, right? So let's go to the next image. There's an image. It looks like a Klingon. Next image, the image of what they look like. So there you have it. And then, of course, but what will happen is that the next group that arrives is the Neanderthals. Let's go here right now. Next image. Okay, Neanderthals thrive between 250,000 to only 40,000 BCE. 40,000 BCE. This is pretty good. The Neanderthals, they are very closely related to modern humans. In fact, 99.7% of their DNA is identical with us. By the way, with chimpanzees, it's 98.8 in common. In comparison to Homo sapiens, Neanderthals had a bigger body, shorter legs, with a cranial capacity that were actually larger than modern humans. So, in fact, Neanderthals, even though they had short legs, their bodies were long, and on average, they were taller than modern humans. So, on average, Neanderthals stood around the men stood around 6'5" to 6'6", while the females were 6 foot to 6'1" in height. So the Neanderthals are very tall, very tall. So we take a look here, and although let's take a look at the next image. I guess I should show you the difference in their heads. There it is. Guess which one is a Neanderthal? That's right, the one on the right. Although we do not have a Neanderthal body that still retains its flesh, most scholars believe that the Neanderthal were covered in body hair to keep them warm, to the point where they may not have felt the need to wear too much clothing, other than, maybe a coat or maybe a poncho, right? The Neanderthal skull reveals larger eye sockets, which appear to support the fact that they had better vision than modern humans. But they also, they will say that the brain was wired for vision as opposed to other functions. Now, there's a few, like Lunte Pierce from the University of Oxford says that Neanderthals evolved at higher latitudes and also have bigger bodies than modern humans. More than the Neanderthal brain would have, she says, have been dedicated to vision and body control, leaving less brain to deal with other functions like social networking. I don't know. I'm not sure I agree with that, but although we do know that they had some problems when it comes to socialization, we'll talk about that in a little bit. Neanderthals lived together. They did in smaller groups. We'll see me for a little bit. In smaller groups. They did, smaller groups, but for example, the skeletons of 12 Neanderthals discovered in El Cedron in Spain are believed to have been a group killed and butchered about 50,000 years ago. Analysis of the mitochondrial DNA showed that the 3 adult males belonged to the same maternal lineage, while the 3 adult females belong to different ones. This suggests a social structure where males remained in the same social group and females married out, because you got to keep the genetics going. You got to keep the diversity. We have also seen this kind of behavior in various primates as well. You just got to diversify the gene pool for adaptation reasons, right? Okay, so we know that Neanderthals did make stone tools. They were hunters. They also knew how to use fire. Typically, they were carnivores. How do we know that? Of course, we have found their fossilized coprolites, their It's called paleo poop. We found their poop, and in their poop, we see red deer, wild boar, aurochs, ibex, reindeer, and so very often we see elephants, rhinoceros, and mammoth. Did you guys know that the rhinoceri used to move about that was now the south of France? I'm just trying to imagine that. One isotope analysis done in 2010 of a Neanderthal teeth revealed the existence of cooked vegetable matter. So they did have some vegetables. So we do know that they did from this cook their food. So they want to cook food. Now, we also realize that we know that they were not only the majority was meat. In fact, there's other studies that go into it. I won't go into these studies, but it is basically a meat diet. But that means every kind of meat. It also means human meat. There's evidence of cannibalism in some cases. I guess you get real hungry. Your friend becomes more than a friend. So what will happen is we've seen evidence of that as well. Yet the evidence, there's an exception. There's always an exception. I always think this is funny. Even though the majority of the studies, like the Findaji Cave in Croatia and others, the majority of the studies show that Neanderthals mostly ate meat because we look at what they leave behind and we see very little in a way of vegetative matter. There's always a group. So what will happen is that there's one group of Neanderthals from El Cidrón in Spain. There's no evidence of meat eating whatsoever. So these are your vegetarian Neanderthals. In fact, they take a look at their diet. They seem to eat a mixture of forest mosses and pine nuts and mushrooms as well, known as the split gills. So most Neanderthals eat tons of meat, but you got this outlying group of Neanderthals that say, hey, we're vegetarian. So there you have it. Did Neanderthals deliberately bury their dead? This has been talked about quite a bit at various places, like at the cave at Chapelle-aux-Cinq. Seemed to be a deliberate burial. It was just contested, but recently they said, yes, it looks like that the Neanderthals did intentionally bury their dead in this sense. Now, what will happen is when it comes to art and so forth, they went from, during the Paleolithic age, went from the mimetic period to the conceptual period, where now you see conceptions that are within the stone tools. What that basically means is that before, they could use this particular rock, hit it a few different ways and use it for different things. But now they're deliberately making stone tools for specified reasons. This one is for hunting. This one is for digging. Does that make sense? This is for cleaning up hides. Different tools, so tool variation. And then what happens is around 500,000 BCE, we move into a third level of tool making. It's called the abstract ideal modeling. And what happens in the middle Paleolithic age, and by this period of time, you're going to start seeing abstract ideas. So while you started before, you're mimic, you're mimicking your surroundings, then you move to concepts. Now you're going to move on to abstract ideas. So we are developing, our brains are developing, and we see the first instance of Neanderthals using red ochre paint in various contexts around 250,000 BCE. We see this, for example, around Maastricht, which I've actually been to. So yeah, these crazy Neanderthals. Now, I do want to mention that what happened to the Neanderthal? They're spreading everywhere. The Neanderthals, basically, though, when they migrated into regions of the Middle East, and then they migrated into Europe. They're a dominant group in the Middle East and into Europe, but not East Asia. There's another group there we'll talk about in a few moments. So this species, their migration area is Europe and the Middle East. But what happened to them? That's an interesting story. The story is so interesting that the full analysis of this idea came about in the year of 2024. Yes, in fact, it was even updated within the last few days. I mean, so this is really fresh materials. In fact, a lot of this stuff is new stuff. So while many, it's called many believed the Neanderthal population was genetically homogeneous. Researchers have recently found that there were two populations of Neanderthals in Western Europe. And while they lived close together, often as close as a 10-day walk, for some reason, these two groups left one another well alone, and they did not mix. In fact, get this, they did not mix for 50 millennia. That's a long time not to mix. You can see this is intentional. Were they becoming more insular as time went on? Of course, constant interbreeding will lead to less genetic variation, right? And this could have affected their ability to adapt. Also, of course, with less social interaction, made sharing new ideas across a wider area less possible. If this tendency continued, it could be a factor that led eventually to their extinction. There is other evidence leading to the idea that as time progressed, Neanderthals began to form even smaller communities. They seem to be less curious than Homo sapiens, wishing to stay closer to home, not wanting to venture out too far, and then constantly intermarrying with one another. Now, while we find Neanderthal DNA in Homo sapien fossils, it is rare to find Homo sapien DNA in Neanderthal fossils. What does this mean? It reveals that apparently the Homo sapiens were proactive in the inbreeding as they migrated, while the Neanderthal were not. And so their populations continue to dwindle. So it is the Homo sapiens, that darn curiosity that we have, that, looking into places we shouldn't, that desire to just know what's behind the next corner, that feeling that, hey, we want adventure, we want to go to different places, we want to experience new things. This is part of us genetically, sort of, because we got Neanderthal in us too. So that's going to happen. So maybe the idea is, do you want to go out and do the Homo sapien thing, or do you want to stay at home like a big old Neanderthal? Of course, I like to be a Neanderthal half the time, so I'll be watching the TV or reading a book. Okay, I'm stopping. No laughing here. No laughing aloud. Okay, moving right along. There is yet another species. We talked about, of course, you did have, remember the Homo heidelbergensis? Yeah, they're still around. So they're migrating east into Asia, and they developed into the Denisovans. The Denisovans. Let's go to the next image. The Denisovans. There we are. We do not know much about the Denisovans, for all that has been discovered so far are just a few fragments of bones, like a finger bones and two teeth and a toe bone. And but we do have a scatter of bones. We keep discovering more every year. So we're not getting a whole picture. But anyway, taking a look at, for example, the finger bone of the mitochondrial DNA revealed that they share a common origin with Neanderthal, but also the Homo heidelbergensis. We also know that they arrived early out of Africa. They arrived around 200,000 BC, and they migrated to Siberia as well as Southeast Asia. The Denisovans also mixed with modern humans. 3% to 5% of the DNA, those of Melanesia and Aboriginal Australians are from the Denisovans, by the way. So we know that. We also know that, let's go here, that the Neanderthals and the Denisovans diverged from a common ancestor, some say about 400,000 years ago. So as I said, the Neanderthals went to the Middle East and Europe. The Denisovans went to East Asia. And so it turns out through various mutations, there's about 300,000 genetic differences between the Denisovans and the Neanderthals. But the two typically did not mix. But there's always exceptions. In fact, there is exceptions. About 200,000 years ago, DNA from a Siberian cave does reveal such a mixture did occur, and apparently repeatedly. So a Neanderthal male was discovered with a high quality genome, and of course there is Denisovan DNA. So it's interesting. We also note that these aspects connect to a robust lower face, and there's also this Denisovan, or Neanderthal, excuse me, had a larger molars than typical Neanderthals. So we're seeing where this comes from. We do know that the Denisovans loved eating blue sheep. We also know they ate woolly rhinos, wild yaks, various birds. They were hunters. They were butchers. They had thrived especially in the Tibetan plateau for around 100,000 years. But we recently found evidence that the Denisovans survived through a rib bone. This rib bone was dated between 48,000 to 32,000 years ago. So that's not long ago. So the Denisovans were around. Let's go. So I do find that interesting. Let's take down the image real quick. And I know you want me to talk about this. Come on. There's another extinct species that are connected to us. They're called the Homo florensis. They're also known as hobbits. So one was discovered in 2003 at Langwa in the island of Flores in Indonesia. In all, fragments of skeletons of 9 individuals were recovered, including one complete skull. And it was determined that their average height was about 3 feet 7 inches. They're pretty small. They had very small heads with the brain capacity of a chimpanzee. The brain was half the size of Homo erectus, for example. Yet despite their small brain size, they also used stone tools. They hunted collectively and effectively, and they used fire for cooking, as discovered in their cave. They, again, became extinct around 50,000 years ago, but not too long ago. So now we realize that we have lots of hominid, I should say, migrations, right? So we're getting the stage set for yet another migration. You want migrations, you're getting this. So you got the Neanderthals in Europe, right? You got the Homo heidelbergensis moving into Asia. You get the Denisovans. You have them in the areas of Siberia and Southeast Asia. And then you got these hobbits, right, in Indonesia. They're all spread out, and they're all ready for the next group. And that's, of course, modern humans. So modern humans, known as Homo sapiens, lived in Africa. And we're going to be talking about what is known as the mitochondria Eve. Let's go to the next image. The mitochondria Eve. There we go. Oh, there you see it. Living in Africa. Mitochondria Eve lived between 200,000 to 120,000 BCE. Now, mitochondrial Eve is the matrilinear, most common ancestor of all modern humans currently living today. Everyone, we are all related. Every single one of us. This again, 200,000 BCE to 1,200,000. So 1,020, excuse me, 1,000 BCE. So you have this relation. We're all related to this ancestor. This is our great forever grandma. We all descend in an unbroken line from this one woman, as can be traced through all mothers. All mothers. While we all share the same general mitochondrial DNA, there are still variations since mutations have come about. But otherwise, we have this DNA in common. This mitochondria Eve can be traced directly back to Africa. I told you that this talk will be about unity. It will be about bringing people together. Well, guess what? How much together can we get when we can all claim, every single one of us listening to this talk, no matter what background we are, we can all claim that we're all related to her. Now, around 100,000 to 80,000 BCE, three main lines of Homo sapiens diverged in Africa. We can trace the migrations of modern humans out of Africa through the examination of variations of the human mitochondrial DNA haplogroups. Now, let's talk about this. What is, and we have to know this, what is a haplogroup? Haploid from the Greek, which means one-fold or simple, is a group of similar haplotypes that share a common ancestor with a single nucleotide polymorphism mutation. More specifically, a haplogroup is a combination of alleles at different chromosome regions that are closely linked and that tend to be inherited together. So as a haplogroup consists of similar haplotypes, it is usually possible to predict a haplogroup from haplotypes. And so haplogroups pertain to a single line of descent, usually dating back thousands of years. As such, membership of a haplogroup by any individual relies on a relatively small proportion of genetic materials possessed by the individual. So what we do, and what we're going to be doing, is we're going to be tracing these haplogroups as they change, and from that and the archaeological record, we can trace where people went, and not only where they went, we can trace when they got there. I think that's exciting. And I'm going to take you on that journey right now. We start here, of course. You see, you got the L1, L2, and L3. So via this strategy, we can determine that Homo sapiens, a mitochondrial haplogroup, LP, or also known as A or Y DNA, colonized southern Africa and were the ancestors of the Khoisan peoples, who are divided into Bushmen and those known as the Khoi, once called Hottentots. Both groups dominated much of South Africa before the arrival of the Bantu-speaking peoples, and currently occupy the nations of South Africa, Namibia, and Botswana. This group arrived here around 100,000 to 90,000 BCE, and remarkably, they have been there ever since. They are still there. So they migrated there, and you can see their L1 right there. They migrated there, and they are still there. Now, I have to say the Khoisan, they used to be actually the largest population on Earth at one point. The Khoisan peoples, by the way, we know they're very unique from other languages in Africa because their language contains click consonants that were later adopted to, for example, by the Zulu. So they're not only using voice, they're also using clicks as part of the language. It's a very ancient custom. So there you go. so those who possess haplogroup L1 settled Central and West Africa, were the ancestors of the Western Pygmies. So you get the Pygmies arriving there around 110,000 BCE. So I'm going to say this, and they have not left. So once again, the Pygmies are here in this area of this area of West Africa, and they have not moved. Well, they kind of moved into the more deserted regions because of the Bantu. And those who bore haplogroups L2 and L3 and other mitochondria remained in East Africa, and they became the ancestors of Niger Congo and those known as the Nilo-Saharan, the Nilo-Saharan speaking peoples. They were here, here's more of an exact date, since 107,000 BCE. So you have a large portion of groups here of L0, L1, L2, and L3. Once they move just a little bit away from where they originated in East Africa, but then they stay and they remain. This is not the story in other places, but it is the story here in Africa. Now, Homo sapiens then migrated into Europe and Asia between 125,000 to 60,000 BCE. The haplogroup L3, which remember connected to the Niger Congo or the Nilo-Saharans, they were the dominant group in Northeast Asia. This group eventually will move, will expand. They'll still be there, but they'll expand out of Africa, and they'll eventually divide into the macro haplogroups known as M and N. Now you're going to see a few charts coming up, and you're not going to see an M and N. I'm going to tell you, don't panic. Those are the sub-haplogroups that are, sometimes they go back and forth. So you'll see both on the map. Sometimes they have one or the other. But I still want you to understand that from L3, from the Nilo-Saharan groups, will, as they move across to Europe and Asia, they will split into what's called M and N. But M and N all draw from L3. So out of Africa. And so we all outside of Africa, unless, of course, obviously intermarriage and going back, but I'm just saying we'll have either an M or an N in us. For those who are from Africa, they will obviously not have M and N. The other interesting part is that if you were originally from sub-Saharan Africa, your background, this also means, which is very exciting, this also means that you have a situation where you have no Neanderthal in you, no Denisovans, you have none of those other groups. So in a sense, more pure actually than the other groups that will intermarry as they intermix as they spread across the globe. Okay. All right. So that's where we have that. Okay. Let's go to the next image. So you can see how it will start spreading across in all these different areas, right? So you can see them on the move, right? So humans are now spreading about. So what will happen here? Of course, when Homo sapiens migrated to Eurasia, they entered areas already occupied by 4 other known Homo sapien species. Homo species. Of course, we have the Homo erectus in Eurasia. You have the Homo Neanderthals, right? You have the Denisovans. You have, of course, the hobbits, right? They're all there. And so as we Homo sapiens spread, there will be intermixing. Now, there is a possibility of yet another Homo species that thrived between 70 to 30,000 BCE, but we're still doing more research on that. But of course, as humanity spreads over all these continents, we encounter earlier forms of humanity. And so, but what I find is interesting, this is a fun fact. Did you guys know that in the Near East, at first, entry into the Near East was flatly denied by the Neanderthals? So what happens, the Neanderthals actually block the Homo sapiens from entering into the Middle East and then going on to Europe, specifically the Levant area. They block them, and so the Homo sapiens have to actually go backwards and go the other direction. And eventually they'll get through the Neanderthals. Neanderthals actually make their stand. Now, of course, it still is determined that 20% of Neanderthal DNA continues to survive in humans today. In fact, recently we have learned within this last year, this is again brand new news, that the Homo sapiens and the Neanderthals actually interbred, we now know, originally, at least the first time, in the Zagros Mountains. These are the mountain range along the Persian Plateau, which had a very diverse biosphere. So this is where they finally kind of interact. So it is determined that 20% of Neanderthal DNA continues to survive today in modern humans. So what happens here is that, unfortunately, we get lots of diseases from this mixture. In fact, what happens is 70% of Europeans have variants of genes that connect to Neanderthals, including, of course, diseases of lupus, cirrhosis, Crohn's disease, type 2 diabetes. So, yeah. Also, another fun fact is that Neanderthals give another gift that's better than the diseases, and that is red hair. Red hair arrives from the Neanderthals. Yep. So the genetic variant of the MC1R gene linked to red hair in Neanderthals arrives to us. We know that there's that intermarriage. Now, in the other directions, we know that when the humans arrive in East Asia, they mix with the Denisovans. It turns out that the Denisovan DNA makes up about 0.2% of all the DNA of those living in Asia as well as in the Americas. So there is indeed a mixture there as well. As I mentioned before, Denisovans ancestry is shared by Melanesians, Australian Aborigines, and groups of Southeast Asia. So there you have it. Now, let's go to the next image. Modern humans did reach the Levantine corridor before they were so forcefully pushed back eventually by the Neanderthals. They did arrive here around 125,000 BCE, and they settled here for a period of time. Let's go to the next image. And what they found is, of course, the Skull Cave in Kafsa, Israel. Around 90,000 BCE, we have now Homo sapiens. We find skeletal remains that were stained with red ochre, and they're surrounded by grave goods, with one of the skeletons holding a mandible from a wild boar. It became pretty evident from the discovery that these are ritual acts that mean something. In fact, in total, there are about 7 adults and 3 children buried at this cave. So what happened is that obviously the flesh would have to be removed in order to paint it red. What does the red represent? There's different theories. Some will say, well, red, because it's red, it represents blood, and blood is looked at as a life force. And so if you paint the bones red, then what you're doing is you're giving the bones life. and maybe it connects to some kind of afterlife. Now, these are just ideas, these are just speculations, but it's interesting. But as I said before, the Neanderthals made their stand. They basically said, no, we are not going to let you in. And so what will happen is humans are forced to now go a southern route out of Africa. No, don't worry, they're going to let them through. And so around 100, so next image, so around 125,000 BCE, they were blocked by the Neanderthals, next image, along the Levantine corridor. And so as a result, Homo sapiens were forced not to go to the Middle East at first, and were forced to go another direction. And that goes to the next image. I'm sorry that the helper groups have different because there's a whole bunch of mixture going on over the centuries. So this is kind of a more all-inclusive one. So eventually, what will happen is humans will have to go from Ethiopia across Africa to Ethiopia to Yemen, moving across the Bab el Mandeb Strait in the Red Sea. Let's go to the next image. This strait was narrower at the time because of the lower sea level. And so it was a very well frequented route. So then from there, once crossing the Red Sea, modern humans reach what is now the United Arab Emirates. And then Oman around 106,000 BCE. Modern humans then arrived in what is now southern Iran and split, with one group heading for the Fertile Crescent and occupying much of the Near East, moving from there into Anatolia and eventually into Europe. The other group continued on going eastward towards the Indian subcontinent. Yet eventually, around 50,000 to 47,000 BCE, modern humans again chose to move over the Levantine corridor, often called the northern route, and apparently nothing stopped their progress this time, moving first through Sinai, Israel, and Syria, and then continuing on to the Near East. By the way, the first evidence of modern Semitic peoples arrived much later from the Halpo group JP58 in the Near East at the time of pre-pottery Neolithic B. So around 7,600 to 6,000 BCE. This is the earliest known connection directly to the Semitic peoples. And they occupy much of what is now northeast Syria, northern Iraq, eastern Turkey towards the Mediterranean, Anatolia, and so forth. Palestine, modern Egypt. So there you have it. Now, what happens, next image. Now, whether from the northern or southern route, most likely both, modern humans reached the Indian subcontinent by 75,000 BCE. These are known as the Vedic peoples, and they thrive between 70,000 to 60,000 BCE. And these people eventually will be the earliest inhabitants of Sri Lanka, where many of them will stay. And then, of course, following this, way later on, let's go to the next image. What will happen is around 8,000 to 7,000 BCE, the Mundas arrive, and they arrive from the Austroasiatic area. Basically, they arrive from Southeast Asia. They're the next group, but it's kind of a far between 70,000 BCE was the first group, and then we have to wait till all the way to around 8,000 BCE for the second group. So see, there's the Mundas, but they come from South China via Burma, also from Cambodia, Vietnam, Laos, Java. And then next come the Dravidians. Now, Dravidians, they arrive around 6,000, although some will say 7,000 BCE. But as opposed to focusing in on the eastern section of the Indian subcontinent, which is where the Mundas will be focused upon, the Dravidians will focus upon the south and western section of India. And they're the Dravidians, they're the ones who form the very advanced Indus Valley civilization. What I find is interesting, and you need to hear this. This is where, for me, this gets fun. The Dravidians originated from where? Well, they go back to Elam in the Fertile Crescent, which is southwestern Iran today, and were agriculturalists. Well, where are they from? Actually, before this, they did originate from Africa, around Ethiopia. So the Dravidians, by the way, are of the haplogroup HM69, which can be traced directly back to Elam. So what will happen is that the Dravidians are from this area, but originally from Ethiopia. And the Dravidians are there to this day. So the Munas to this day are the people who are now settled in much of Eastern India. And the Dravidians, although while they dominated much of India in the south as well as the west, when the Indo-Europeans arrived later on, they get pushed down south of the Deccan Mountains, and today the Dravidians dominate that particular region. Next, of course, next image. Next, of course, humans continued toward Southeast Asia and into Indonesia around 70,000 to 6,000 BCE. When they arrived here, humans split, with one group moving north along the coast of East Asia up to China and Japan. Reaching here humans arrived here around 50,000 BCE. And the second group continuing on down towards Australia. So today, of course, go to the next image. Today, M is the single most common mitochondrial DNA haplogroup in Asia. It peaks in Japan and Tibet, where it represents an average about 70% of maternal lineages. And of course, we see this also in India and South Korea, where it's approximately 60%. Among Chinese people, both inside and outside of China, haplogroup M accounts for approximately 50% of all mitochondria on average. But there has some variations. Meanwhile, haplogroups A, B, and G arrived in Siberia, Korea, and Japan around 33,000 BCE. So we have another group, a migration swinging on through. There's a Paleolithic site at the Yana River in Siberia that is higher than the Arctic Circle, dates around 27,000 BCE. So it shows humans getting pretty far up. Let's look at the next chart. I find this interesting. So there we go. So you can see how the haplogroups frequencies arrive in different places. Yet, next image, yet as humanity swept through the coastal areas of East Asia, other groups began to head back west from China as early as 50,000 BCE. And we know that they then arrived in Western Siberia around 45,000 BCE, especially as evidence from what's called the Ust-Ishman-Man. Let's take a look, next image. This, of course, these basically dating from 43,000 years ago. It's one of the first humans to live in Western Siberia. That's 43,000 years ago, with his fossil preserving his DNA, and so preserving the complete sequence of the genome. Of course, he belonged to the first wave of humans to migrate out of Africa into Eurasia. And so this is pretty important stuff. But here we go. Here we go. More fun. Let's go to the next image. As for North America, Paleo-Indians originated from, indeed, Central Asia, crossing from East Siberia and Alaska over what was once the Beringia land bridge that existed due to the low sea level from the last glacial age. They followed the extent animal game and extensive Pleistocene megafauna along this ice-free corridor. Most scholars believe that the first Homo sapiens arrived via the land bridge between 16,000 to 13,000 BCE, although this is still contested. Some say it is earlier, and some say maybe a little later, but most say a little earlier. We know that the Siberian people and cultures have a direct link to the peoples and cultures of Alaska and northwestern Canada. Now, let's go with the DNA, next image. So here we go, DNA evidence. Upon entry to the Americas, it appears using DNA evidence that the new arrivals very much moved southward along the coast, initially having the QM242 mutation upon arrival, but then as they moved southward, took on the QM3, also known as C3 mutation, which dominated the Americas clear to South America. Another group, the Helpo CM217, also known as C2 and previously C, which originates from Eastern or Central Asia and is found in northern China. This group too crossed over to the Americas a little later, but focused more on the northern regions. Let's go to the next image. Another group is Helpo group CM217. C2, oh, sorry, another group, sorry about that, remained emerging for a time and did not move further to the east for a while. Those that eventually settled in the northmost areas of North America, Greenland, arrived here long after the occupation of South America. We have, of course, the Nadain, Inuit, and other Alaska populations still exhibit the earlier Helpo group QM242, making them distinct from the others who migrated further south. But also, you got something strange going on. You see a little question mark here. Yeah, and I don't know where we go with this. I'll just say this and just stop. There's also those in the north that have a mix of R1, which is connected to Eurasia, and has been theorized that this group arrived in this region after the Ice Age, and so sometime around 13,000 BCE. Well, R1, of course, is interesting because it's coming from the other direction of Europe. And as we know, R1 will become the Indo-European Helpo group. So it turns out, at least the mitochondrial DNA is saying that, yes, we have a migration that we are traditionally taught that came across Alaska, came across that land bridge between Siberia and Alaska and moved down, but also appears that you have another group arriving via Europe and Greenland into what is now Canada, in the northern part, what is now the United States. So you do have an interesting situation which is hardly ever taught, and that is the migrations come from both sides. Let's go to the next image. The earliest DNA evidence for humans was discovered in the form of fossilized human coprolites, discovered at the Paisley 5 Mile Point Cave in South Central Oregon. This dates from 14,300 BCE. I spared you from seeing the actual remains, which are remains. So you have the next image. The Halsuk Nation, an indigenous group in British Columbia, claimed that its ancestors fled for survival to a coastal area in Canada that never froze during the Ice Age. And now excavations at Trinquet Island, located in British Columbia's central coast, has backed up that claim. They discovered an ancient village, including carved wooden tools and bits of charcoal in a thin horizontal layer of soil. And it dates back to around 12,000 BCE. So we do, that's pretty darn early. Let's go to the next image. Then around 11,200 to 10,900 BC, you have, of course, the Clovis culture, which appeared today throughout the central part of America. You have, of course, the double-sided fluted stone spear points and so forth there. Let's go to the next image. And you can see more evidence of these fluted points. We don't have a lot of time, so I will just keep on going to the next image. You can see that they move on, humanity moves on to South America. Now, recently we have discovered that there happens to be another movement where we have a DNA that does indeed arrive from the South Pacific. They are island hopping and enter into South America from that direction. There's also been DNA from Africa that has been detected in the area of South America early on. So there's lots of stories apparently that we do not know fully about. Let's go to the next image. Now, what about Australia? Next image. In Australia, the first modern humans arrive in Australia. It appears that modern humans reached Australia around 50,000 BCE. And we have determined this. The theory, of course, basically there was a single migration into Australia and New Guinea. And this occurred. Though some others will say that, well, it wasn't 50,000 BCE. Some say it was as late as 38,000 BCE. So there is some disagreement there. But there you go back. That's because the dating gets a little off. In fact, one of the oldest cremation sites were discovered at Lake Mungo. 3 sets of human remains were discovered, and they have determined that they dated between 66,000 to 38,000 BCE. So you see, there is a diversity here. It's interesting that we have detected that when the female died, her corpse was burned, then smashed, then burned the second time before being liberally covered with ochre paint. So there's lots of ritual going on here. It looks like that they are descendant of mitochondria N, and these are the direct descendants. The direct descendants, of course, will be the Aboriginal Australians, and they have been there ever since. In fact, they've been there ever since without too much in the way of change. We've also realized that Australian Aborigines have between 3 to 5% Denisovan DNA. So Australian Aborigines are the oldest living population in the world and possibly the oldest outside of Africa. And they are also said, next image, confirmed to be the oldest continuous culture on the planet. While I agree partly, I will have to kind of backtrack and say that's true, but I also want us to think about the sub-Saharan African groups that they are in Africa. Just the 3 different groups move to closer regions within the continent. But so I would contest that maybe sub-Saharan Africa, those from there would get the prize. But I would say the Australian Aborigines get the next prize. That's my opinion. I'm just speaking from the hip here. Okay. Well, where do we go from here? Next image. Something cool that they made, Australian Aborigines. Let's go to the next one. Yeah, what about the Cro-Magnons? Yeah, in general, there are 3 migrations of modern humans into Europe, with the first, of course, occurring around 50,000 BCE. Now we're focused on Europe. This is the last part of our talk. We're going to Europe now. These being the Cro-Magnons, with their hunter-gatherer lifestyle, who did migrate out of Africa. The second group were agriculturalists who arrived in Europe around 7,000 BCE, mixing in with the earlier population. Finally, the third group were the Indo-Europeans, who were nomads from the Pontic and Caspian steppe regions, arriving here around 2,500 BCE. So you have 3 migrations: 500,000 BCE, Cro-Magnons, agriculturalists, 7,000 BCE. I would actually move that date back to around 9,000 BCE. And of course, the Indo-Europeans, what's typically 2,500 BCE, I would move that back to around 4,000 to 2,500 BCE. I'm always correcting things, but there it is. Now, we're still in the Paleolithic age, and we've entered now, I told you that we first had the mimetic period of time, when it came to stone tools. Basically, it is what it is. We move from there to the conceptual period of time. We have concepts in the tools. We move from there during the Paleolithic age to the third period, which of course is the abstract era, where abstract ideas are seen within the tools. Now we move into what's called the mythic linguistic modeling period. And this means is that now what happens is you see these abstract symbols from the previous period of time, the abstract area, now are put in sequences. Now they're put in more complex orders and reveal that ideas are not only being depicted, but possibly language, and beyond language, possibly stories, possibly mythology is coming about. So there you have it. Now we're talking about the Cro-Magnons. They made their way by this is an image of one, by way of the Zagros Mountains. So the term Cro-Magnon has no formal status. It refers not to a species or a subspecies, not even an archaeological phase or culture. In general, Cro-Magnons are just a type of people. They were robustly built. They were powerful. They had having only slight brow ridges above a short and wide face. Their faces were wider and a prominent chin below. The brain capacity was actually larger than the average humans. So their brains were larger than us. As for evidence of the Cro-Magnons, let's go ahead. Let's go back to me. In Europe and in Asia, human remains dating from 45,000 to 43,000 BC have been discovered in Italy and Britain and other places. So we know that they're around here. Now, as discussed, modern humans encountered the Neanderthals when they reached Europe, and evidence is that these two species competed with one another over their territory, although it looks like the Neanderthals in many ways just curled up and died after a period of time. But there you have it. While the Neanderthals were stockier and bigger, and modern humans had to get used to the colder temperatures. Their bodies were not ready for these changes, especially since they were going through a glacial period of time. Let's go to the next image. You see, between 29,000 to 14,000 BCE, you have the last glacial period, which covered much of the northern hemisphere under a sheet of ice. Now, the ice will retreat around 13,000 BCE, and where the ice was not, dry and cooler temperatures diminished the rainforest with the expansion of savanna land. Neanderthals, of course, will become, they were already extinct by the time of 13,000 BCE. There we go. Okay, thank you for showing that. Let's go back to me. During the I'm choking on water, upper Paleolithic age, we began to observe evidence of two religious beliefs becoming defiant and opposing one another. What's going to happen is you're going to have what basically occurs, I'll just do this really quick, is you have a hunting-gathering society, hunters and gatherers. Here's the problem. So, before 13,000 BCE, you have very much what's an egalitarian society. Homo sapiens are egalitarian. Men and women are maybe doing different functions, but there's still a sense of equality. Just men typically are hunters. Women are typically gatherers, but that's not always the case. What we will see, however, is that the main game happened to be these large animals like the mammoth, for example. Well, what happens is that after 13,000 BCE, as the ice sheets retreat, what occurs is that the larger game, which supplies a lot of meat, go north. They go northwards. And they're replaced by deer, gazelles, rabbits, faster moving animals, which are harder to catch and have less meat. And so what will happen is humanity in these regions of around the Mediterranean all the way across to the Yangtze Yellow Rivers, they have to adjust to this new environment. They have to supplement less meat with more vegetative materials. Of course, eventually this focus will turn into the development of agriculture. So you'll have agriculture coming about. But for those who go north, for those hunters that go north, what will happen here is that they will just hunt the mammoth and they'll think that this resource will last forever. And I told you hunters and gatherers, men were often the hunters, women were often the gatherers. Well, as you go north, of course, you have the soil, which is weak when it comes to nutrients because ice had just recently covered it. And so there is, we know through the archaeology, we can talk about this, there is a lessening, at least at this time, of women in a role as gatherers. But you're going to see when it comes to men in these areas, there's going to be a glorification of the hunter cult that we see that. Another interesting factor is that we know that in the Paleolithic age, they had this idea that the earth, in a sense, is a mother. It is female because it gives life, like a female gives life. So therefore, it must be a life giver. So the earth is connected with sometimes female aspects. But what happens is the area, by default, the sky must connect to sky spirits, sky deities, and so forth. We'll talk about that in a little bit. Well, what will happen is that this group that goes north, that follows the mammoth, they will also focus less on the earth and less on the female aspects there, and focus more on the sky deities. We'll see how that works. But it turns out the glorification, unfortunately, of the male in these areas will give rise to an idea known as patriarchy. So patriarchy is the north, while those in the south are very much egalitarian by nature. But things are going to change pretty quickly, because what will happen is these mammoth hunters, they're going to hunt these mammoths because this is a resource that's going to last forever. Guess what? I mean, they wear clothing made out of mammoth skins. Their food is mammoth. They make weapons out of mammoth bones. Homes are made out of mammoth bones. And guess what happens? The mammoth become less and less and less. Well, as a result of that, as they're fighting over, various people in the north fighting over the resources becoming less and less, they have to defend themselves. Now, I will say very clearly, there's evidence in the South and egalitarian societies of warriors. Don't get me wrong, there are warriors. But in the North, the warrior aspect becomes emphasized, especially since the contest for resources become a little bit more desperate. And so now you have the patriarchal societies that are also more warlike. Well, the resources are going to start going down. And so these groups will have to start going south all the way across the northern section of Eurasia. So groups will now descend down to Mongolia on the Asian side. Well, then, of course, will eventually descend into the more egalitarian societies, will descend into China and to Japan, into Korea, right? But the same thing will happen here in the European side, and these groups will descend into what is known as the Caucasus Mountains. And and of course, these are the so-called Caucasians, or also known as Indo-Europeans. And so what will happen is then the Indo-Europeans will suddenly be on the move. And as they're on the move, they will spread from the Caucasus Mountains. They will go south into Anatolia, and there'll be the Hittites, as well as the Luvians. They will go east into Persia. They will become the Persians. And then between 2100 to 1500 BCE, these Indo-Europeans, also known as Aryans, will arrive in India. And of course, they're connected to the Vedic cultures, right? They will be the writers and speakers of Sanskrit. And so this happens there. Now, let's first go to the Indo-Europeans as they moved to the West. Sometimes this is connected to the so-called Kurgan culture, right? And we take a look and we see with these migrations. Now, it turns out that they start to migrate, they start to leave the Caucasus Mountains around 5,000 BC, 4,000 BCE. They start to move towards the Kurgan culture starts to move around 4,400 BCE. They start to arrive in Europe and they start creating various settlements that were occupied for a period of time. We do know as they move, we can trace their movement every 100 years, as they're actually less than sometimes 50 years, we can trace them through archaeology as they move to the West. We see that the disrupted or changed material culture. For example, originally we'll see pottery that is that's fine ceramic ware that's made by those who had had lived there the agriculturists who had lived there for a period of time. Again, they say 7,000 BC. I say about between 9 and 8,000 BCE. It's fine ceramic ware. And all of a sudden, it's even sophisticated at time and very polished. And it's replaced by these more crude pottery that's made by those that are indicative from the region of the Black Sea region. We also see as they move across Europe, burial patterns change too. For a while, you have communal grave burials, which is really a common practice for old Europe. New forms of graves appear, including the mound tombs and burial graves. The skeletons of those buried in those graves now focused on males, while before the material goods were more egalitarian. They focused on both males and females. Now the dominance of these burials are focused on males, often buried proudly with their weapons and other items, revealing their prestige, and really contrast greatly with the female burials. Weapons are everywhere. While female images and symbols do continue in prominence, they're now accompanied by increasingly images of males, various symbols there. And we also see, which is interesting, we see more and more images of females. They still have nudes, but a lot of them are now being covered up too. So we see, while agriculture continued as before alongside farming, there's more evidence for pastoralism, and we can trace this too. So there is absolutely a movement that we can trace through archaeology that we can quantify and qualify as they move across. And we do see in the material culture a change. Now, I'm not saying that Kabuna's thesis is correct. I'm not saying it's incorrect. What I'm saying is there's still evidence that there is a change that seems to favor more males. There is a change that favors more of those who are warlike, and there is a few other changes beyond that as well. They don't seem, again, to be as sophisticated. So let's take a look for fun at the map. So let's take a few maps. I'll just kind of zip through these. So here we go. So this is the map of early Neolithic Europe, and this is how the various peoples, right? Let's go to the next image. We're just going to fly through these. You can see, okay, you see that the groups are starting to move from the steppes of Russia. They'll be starting to move west. Let's go to the next image. Corded ware culture. You can see them moving across, right? All right, next image. There we go. Okay, so this is, I love this. This is a great map. You can see there are the R1B haplotypes. This is, of course, the DNA that's connected to Indo-European, right? So roughly around 25,000 years ago, so 23,000 BC, the R1A haplogroup evolves directly towards the beginning of the last ice age. One group went towards the Eurasian steppes and the Caucasus, where the haplogroup becomes diversified into R1A1A. And most scholars agree that these are the Indo-Europeans. Next, this group continues west, where they occupy much of Central and Eastern Europe, becoming known as M417, subclads R1Z282 and R1Z280. So we see them moving across here. You can see that obviously Ukrainians and Russians and so forth. In fact, the study goes into the fact that that they also go the other direction, and they go towards, as you see, area of, they don't show Persia here, but they go towards India. So let's go to the next map. Okay, so you see the concentrations here of the haplogroup 1R1B. Let's go to the next image. There we go. So moving towards India. These, of course, where the Aryans are connected. In fact, in northern India, those who have a high percentage R1A1A, which is the Indo-European haplogroup, are the following. West Bengal Brahmins have 72% Indo-European in them. Uttar Pradesh Brahmins have 67% Indo-European blood, and Bihar Brahmins have 60%. That's a lot. So it turns out that it turns out that the highest three castes in India have a higher concentration of R1 haplogroups, which is the Indo-European group. Again, I find this fascinating, but of high concentration, especially the Brahmins. And so you can see that between 2000 to 1500 BCE, they do come in. Let's go to the next image. You can see kind of here the breakdown and how this occurs. Now let's go to the next image. Of course, it's not only through ceramics, it's not only through burial customs, it's not only through their stone tools and their non-stone tools. It's not only through but it's also through their language that we can see the Indo-Europeans as they spread. And so what will happen, as you can see in this tree, you have various, you have a Proto-Indo-European language, and it branches off in various directions. You have, of course, one group will be the Greeks. And so we get, of course, the Akkadian, the Aeolic, the Ionic, and the Doric. So these languages are coming about. You also, of course, have, I should mention, and it's not here, but you also have, before that, you have Mycenaean. So the Mycenaeans are Indo-Europeans. They, of course, take over from the Minoans, who are a non-Indo-European people. Interesting note, the Minoans are egalitarian, the Mycenaeans are patriarchal. So the Indo-Europeans arrive in Greece. Another group, of course, as we talked about, goes towards India, and you can see the languages that arrive from that. You got Hindi, which is there, right? But they all branch off from Sanskrit, which the Vedas are written. We got Hindi, you got Gujarati, you got Bengali, you got Punjabi, and you have Marathi. So these are languages that are Indo-European. So as they just as the DNA haplogroups evolve over time, so do the languages. You have, of course, old Iranian. Indo-Europeans go into what is now Persia, Iran. And so old Iranian is a root of the same language. And you got Persian, Bajito, and Maliche, right? Then you have another branch, and that's the Slavonic group. So the Indo-Europeans then arrive in Eastern Europe. And so the Eastern European languages that are Slavic are Czech and Polish and Great Russian and White Russian, the Ukrainian. You can see here also you got Slovenian, and you got Serbo-Croatian, and you have Bulgarian. Then you have another group. These are the Baltic languages. Once again, these are Indo-European. So as the Indo-Europeans arrive in the Baltic areas, you got Latvia, you got Lithuanian, and you have Old Prussian. Also note that Armenian is also Indo-European. Then, of course, the Germanic languages arrive from the Indo-European. So moving into the West now. And so Indo-European roots include, of course, Flemish and Dutch, Low German, High German, Frisian, and English, Gothic, of course. Of course, you have a group that comes Scandinavian, which, of course, is Danish and Swedish, Icelandic, and Norwegian. Then, of course, what about the Latins? Of course, the Indo-Europeans spread off to Southern Europe and form the Latin branch. So these languages are related to. You got French and Italian, Spanish, and Romanian. So actually, of course, that's going across to Eastern Europe there, Romania, Romanish. And then, of course, you have the Proto-Celtic languages, Gaulish, Scottish, Irish, Welsh, Briton, Cornish, and, of course, Anatolian language going into what is now Turkey, and, of course, Hittite, Palaic, Lydian, Luvian, and Lycian. So you have this spread. So it's amazing. All these languages are all connected together. They are all Indo-European. And so it's kind of like telephone. As humanity spreads to these various languages, these languages do spread and change. So we can trace migrations through language. Let's go to the next. Let's have an example. Oh, yeah, there's a spread right there. I like that. This is, again, where Indo-Europeans are located. Note India, right? Note, obviously, over here, Persia. Let's go to the next image. Here we go. So let's talk about, so I talked about the sky gods, right? The sky deities. So let's use the sky deities. So the Proto-Indo-European, right? So, yeah, we'll talk about Hungarian in a few moments, by the way. By the way, say you brought this up, so I'll bring it up right now. The Hungarian language is not related to Indo-European. So in Hungary, those are Magyars. They arrive at a later period of time, and their language group is completely separate. Also, the Finns, who were there earlier, their language group is also separate. So Hungarian is not related to India or the Indo-European languages. Okay, so we have, of course, the idea of Diwi. Diwi, of course, means sky. It means heaven in this Proto-Indo-European language. And so for those Indo-Europeans, the Proto-Indo-Europeans, those live in the area of Caucasus Mountains, they worship a god by the name of Deus Piter, which means sky father. Now look at this. As they spread, the word changes. So what will happen, for example, when they go, let's see here, there's lots of different directions I can go. Let's go to where is that here? Okay. I don't see, okay. So let's go towards Greek. Here it is. So Proto-Hellenic, you see it goes from Deus Piter, it goes to Deus Pater, right? Deus Pater, and then of course becomes Zeus Pater, right? Zeus Pater, supreme sky god. See how that changed? So Deus becomes Zeus. Now, when the Indo-Europeans go to Italy, Deus Piter in Proto-Italic becomes Jas Pater, and then Oscar calls Di Pater, and of course, obviously in Latin, you have Jupiter or Jupiter, right? Interesting, right? Then, of course, you go across here when it comes to Proto-Germanic. So Deus Piter, Diwas becomes Diwas, God. And of course, later on, it becomes Zu, an old High German, and Tu in of course, in Old English, right? You can see also the various changes. Hittite, you have Deus Piter, will become, actually, in Hittite, you have Zeus, which becomes God. You have the Vedic, Deus Piter, you have Diwas Petar, and Deus Piter in Vedic Sanskrit. You know, I think it's interesting how the Indo-European, pre-Indo-European root doesn't change that much going all the way to India. The word does not change. That's, to me, is fascinating. So you can see the other groups here, but you see how they're all related. And of course, obviously, that word, we also get Dios, Dio from that, right? We also get theos as in theology, right? From that same derivation. So pretty interesting, daemon. But what I want to mention is that there's other words too that have the same, lots of have same roots. That's how we're able to figure out, by the way, ancient Luvian as well as Hittite is because of common words. So other common words would be like, well, of course, father would be father, vater, father, father, right? Mater, mitter, mater, mutter, mother, water. So all these words are Indo-European. They are all related to one another. Again, I just have to say that's pretty interesting. Let's go to the next image. Of course, here's an example of the migrations into India. I just think that's fascinating. Let's go to the next one. I do want to mention one more thing. It's something that may be of interest, but we know that the very first Homo sapiens absolutely had dark skin. The humans who migrated to Europe earlier, around 40,000 to 38,000 BCE, had darker skin. We know that around 6,500 BCE, the early hunter-gatherers in Spain, Luxembourg, and Hungary still retained their darker skin, lacking two genes, that being SLC24A5 and SLC45A2, which would eventually lead to the depigmentation and would eventually lead to pale skin, evident in most Europeans today. Now, you guys want to see that date? Yeah, it's 6,500 BCE. So the idea, so light skin is a recent phenomena. It's a recent idea. Before that, dark skin was the norm, as we know, through this process. You see, dark skin was advantageous in more sunny climates. In climates where it's often cold and cloudy all the time, however, darker skin disrupted the ability to be able to absorb vitamin D through the skin. The story in the north around that same time was different, for they developed paler skin around Scandinavia to be able to absorb more vitamin D. We do find evidence of that. I'll just talk to you. You can see this here. You can see also we're talking about blue eyes as well. So we see what happens is that, for example, around 7,700 years ago, there's an archaeological site in southwestern Sweden where we first come across these light skin gene variants. We also see light skin and blonde hair coming about around that time. And so, yeah, so we're done with the pictures. Thank you so much. So what's going to happen is that this idea the idea of lighter skin and of course blue eyes, we can talk about that too. This came about way later. This came about. This is a new idea. So a new variant of humanity that's around 7,000 years old. One other thing I want to bring up, and just so you kind of put things together, we're talking about unity. Let's go there right now. You look at this, the Indo-Europeans alone, follow the Indo-Europeans. You realize they start migrating from the Caucasus Mountains around 5,000, 4,000 BCE, and they go basically three different directions. They do indeed intermarry with various groups as they move about. In some cases, at first they cohabit, sometimes peacefully, other times they attack. But what I want to say is this, is they still interact and they still intermarry. Why am I saying this? That means that if you are part of any of those groups that I mentioned, if you're part of the groups that are connected to Anatolia, part of those groups that are connected to Iran, part of those groups that are connected to northern India and parts of Afghanistan, if you are part of groups that are connected to the Slavs, Germanic groups, Latins, right? Scandinavians, Britons, and so forth. If you are, by the way, if you're Spanish and Portuguese, remember that R1 haplotype will then cross over to the Americas and intermix with what? With, of course, Latin America, right? So unless you are more isolated indigenous and not intermarried, if you are Mexican or you're from groups that did mix, that means that all of you that I just mentioned are all related to each other only 7,000 years ago. You are all related to each other only 7,000. That's a short amount of time. That's not very long. That is a hiccup. And all of a sudden, you're going, oh, wait a second. The title of this talk makes sense. When you put all this data together and you realize how interrelated we are and how many of these migrations happened recently too, right? You realize that there is we're genetically very close together in so many different ways. But there's more. We are, of course, is that then we pull back a little ways and we go, yeah, but we're also all related to that mitochondria Eve. Not that long before. We're all related together. We're all connected. Why don't we focus on the fact that we are here at the very end of a very long history of the earth? Oh, yeah. Right? In the grand scheme of things, like bookends, I'm doing this, right? In the grand scheme of things, right? we have the idea that we are just the last 2.5 seconds, right, of time, right? Or we are a short bleep at the very end. And so maybe standing in front of this awesome edifice of the past where we did not exist in the form that we did, that these other forms of life dominated the earth, a period of time when you had the ocean creatures dominated the earth, a period when you have the trees dominated the earth, a point of time when the dinosaurs dominated the earth. Now then, of course, a time when the reptiles, the mammals that dominated the earth. We have our time. Why don't we make this time, the very short time that we have, why don't we make the most of it and think to ourselves, let's focus more on what brings us together than what divides us. Also, the other cautionary warning, and the reason why I went through all this, is the other part is that if you hadn't noticed, and I didn't mention them all, our planet almost went extinct, completely extinct, many different times. But the earth continues. I know that we think to ourselves that, hey, we're always thinking that, we're going to destroy this planet. But I think more realistically is the planet is going to continue on. We just have to be careful not to destroy ourselves. So as a historian and as an archaeologist, I plead for you, why don't we start to learn the language of unity? and even focus on this kind of evidence. We spend so often talking, fighting about how different we are, and yet just a short spans of days, and you were related to each other. Why do we do that? So what I'm going to say right now is I just got to make some kind of conclusion, and I'm going to say, why don't we just seek for the stars, do the best we can, love our fellow human, and learn to speak the language of compassion and empathy. Thank you so much.